Alright, so this is installment 3 of the Astronomy Extra Credit. Hopefully you've at least done this. Some of you may just be adding this one because you've seen your grade or you didn't do the project or whatever the case may be. Welcome. Let's get to it. So today it's going to be the modern view of the solar system. Previously, before the solar system was viewed as the Earth being the center of the solar system. This is called a geocentric system. Now, we know that it's not actually a geocentric system, but it's actually that everything revolves around the sun. That's why we call it our solar system. It's so we're going to go ahead and take a look at that. Most of you have probably already known that, but just a quick, let's bring you up to speed just in case you didn't know that, and we'll get to it. So, first off, what are the planets in our solar system? Well, the planets in our solar system, in order, are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now, in your book, it lists Pluto, but Pluto is actually not considered a planet anymore. It's actually considered a dwarf planet. There are a couple of reasons for this, one being its size, but two being its orbit. Its orbit actually intertwines with some of the other orbits with Neptune. So there's also a couple other reasons, but we don't need to go into that too much. However, currently Neptune is not considered a planet. So we have 8 planets in our solar system, all revolving around the closest star to us, which would be the sun. Now, keep in mind, the sun provides all the light for all the planets. Stars are always the objects that provide light for any sort of planet. Planets don't provide light on their own. It's just a reflection of the stars' light. So, again, Earth, we don't have light of our own. We just use the sun to provide light during the day. That's why on the North and South Pole there will be times where they go weeks and even a couple months without any sun at all, because they're not facing the sun, and if you're not facing the sun, you don't get light. So that's one thing to make sure that you remember, is that the sun and stars provide all the light for any planet in our solar system. Now, here is a look at our solar system. Again, the sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto's mentioned there, although this is somewhat of an old picture. Now, how do planets orbit around the sun? Well, some of you may think, oh, well, it's circular. Well, not exactly. Planets orbit around the sun in an ellipse, which is basically an oval shape, which may be elongated or nearly circular. So it's almost circular, but not quite. They actually revolve around the sun in an ellipse. So it's slightly, basically like an oval. That gets to be important when you're talking about times of the year and things like that, and how close you are to the sun. But just for now, all you need to know is that the planets orbit around the sun in an ellipse, which is basically an oval. So to continue with that, here are the views of the orbits around the sun. Now you can see that they're not perfectly circular. They're oval shaped. So you can see just from tracing a few of these that it's an oval. It's not a circle would be perfectly circular. Wow, that's a terrible circle. Don't draw that circle. But a circular, let's try this again. Circle. There. So that would be a circular motion, but you can see that the planets work more in an ellipse. Okay? Now, what is a moon? Well, we know about our moon. It's gray, it has craters, and it revolves around the Earth. However, it's not the only moon on our solar system. Our moon's not the only moon on our solar system. Hopefully this isn't new information. But if it is, now you know. Now, the word moon, or all a moon is a natural satellite that revolves around a planet. Now this is our moon, pictured here. You can see all the different craters and things like that. But that's the thing we see at night. Now, from phases of the moon, you can see that this is a full moon. Whereas if it were to be, let's say, partly gone, you would have a half moon or moon from the first quarter. So it would look like that. Now again, remember, the only time the reason we get phases of the moon is simply from reflection of sunlight. Okay, so we would see sometimes this just simply because that's the side, the angle that we're at, that's the side that gets sunlight, and that's what we would end up seeing. So it would look something like that. So if you don't remember phases of the moon, go back to the second installment and review before you take the extra credit test. But a moon is simply a natural satellite that revolves around a planet. Now we've put up quite a few different satellites around our planet, but a moon is a natural, keyword being natural, satellite. Okay? Natural satellite. Now, here are some of the moons of the solar system scaled to the Earth's moon. There are actually more than what's listed here, but just to get an idea so that way you know the sizes of some of the moons. Now you can see our moon is over here on the left. I'm going to circle this. That's our moon. Now all the other moons are scaled compared to our moon. So you can see that, for instance, Jupiter's moons are relatively large in size, kind of like our moon. This one would be smaller. However, you can see that this one's larger than our moon. And you can see that Saturn has quite a few small moons. So does Uranus, Neptune, and things like that. Alright, so again, a moon is just a natural satellite that orbits around a planet. So these four orbit around Jupiter, these orbit around Saturn, and so on and so forth. Alright, so continuing. How are distances measured in the solar system? How are distances measured in the solar system? Now we can't measure them simply by miles. That would be way too many to count, and it makes it a lot more complicated than it needs to be. So what the scientists have actually done is they've used astronomical units. Now, what are astronomical units? Well, astronomical units is a unit that's actually equal to Earth's average distance from the sun. So that's actually 150 kilometers, 150 million kilometers. So that's quite a distance away. If we had to use that, we would go into these astronomical numbers that are just way too large. So what we do is we make this 150 kilometers, 150 million kilometers equal to 1 astronomical unit. So instead of 150 kilometers, we say 1 AU. So if something's 300 million kilometers away from something, we say 2 AUs, and so on and so forth. So this will be a little easier to understand as we go to the next picture, which should be not here. In any case, there is a picture on page 542 and 543 in your textbook. Now you'll see that, for instance, Mercury is 0.39 AUs away from the Sun, whereas Neptune is 30 AUs from the Sun. So that's Neptune is quite a ways away from the Sun. If you calculate that, that ends up being roughly 4,500,000,000,000 miles away, million kilometers away. So it's quite a ways away. Go ahead, and that should be the end of the notes. The fourth one will be up on Wednesday. Any questions? Please let me know. Thanks. Go Ducks.